Welcome Rosumi Smarika. Everyone, I would like to welcome you to online class. Alright. Rahul Kimi, I would like to welcome you. Let me repeat what we learned last time, okay? Alright, anyway, so last time we learned about the calculation of volume of solid, okay? How do we calculate the volume of solid? I gave you some formula last time. We calculated the volume of cube, which is given by the formula L into L into L, that is called L cube. Similarly, we calculated the volume of cuboid, and that can be calculated by the formula L into V into H. All right. And similarly, we calculated the volume of cylinder. Okay. All right. How do we calculate the volume of cylinder? By using the formula pi r is to h, isn't it? All right. So that is the formula to calculate the volume of cylinder. Okay. And so today, so basically, it is very easy to calculate the volume of solid because solids have some kind of like basically, if we talk about the regular solid, we can calculate the volume of regular solid by calculating their length, breadth, and height. Okay, that becomes easy. So if any object which is regular, that is called if any object which has length, breadth, and height, definite length, breadth, and height, or which appear in proper shape, that is said to be regular body or regular object. So it is very easy for us to calculate the volume of regular body because we can use formula, isn't it? Simply by using formula, we can calculate the volume of regular body. But how do we calculate the volume of liquid? Okay, and you know one thing, liquids are those substances which do not have appropriate shape. Okay, liquid is a substance which does not have accurate, or you can say appropriate shape. Because let's say let me give you one example. Let's say we have a water. All right, we have some water, and if you put that water in a vessel, let's say if I put water in this bottle, then the shape of water will be like the shape of this bottle. Okay, and if I put that water in a plate, the shape of that water will be like that of plate, isn't it? That's right. Water or liquid is a substance which does not have the finite shape, but still we can calculate the volume of liquid. Okay, did you get the point? We can calculate the volume of liquid by the help of measuring cylinder. Did you get the point? We can calculate the volume of liquid by using measuring cylinder. Okay, so let me share the screen and I shall show you the picture of a measuring cylinder. Okay, let me share the screen. So okay, so this is called measuring cylinder. Let me show you the picture. Okay, so this device is called measuring cylinder. I hope you can see it clearly. So this device is called measuring cylinder. You can see the labeling there: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And on the top you can see ml. Ml stands for milliliter, okay? Or it could be liter also. Did you get the point? So this is called measuring cylinder. So by the help of this measuring cylinder, we can measure the volume of liquid. Right now, in this case, the volume of liquid is, this is 60. And let's say it is the 65 ml, okay? By reading this number, by finding the level of liquid, okay, in this case the level of liquid is 60. 60 is here, let's say it is 63, okay? So in this case the level of liquid, that is 63, hence the volume of this liquid is 63 ml. Did you get the point? So this is called measuring cylinder, and by the help of measuring cylinder we can calculate volume. Okay, we can calculate volume. We can calculate volume of liquid by measuring cylinder. So I showed you the picture of measuring cylinder. All right, so by the help of measuring cylinder we can calculate the volume of liquid. Okay, this is the picture of measuring cylinder. See here. All right, okay, it is made of glass or plastic. So I think this is glass. All right, and it is transparent. All right, so that we could see the level of liquid, which is why it should be a transparent. Okay, and by the help of measuring cylinder we can calculate the volume of liquid. Okay, all right. Okay, all right, so you might have heard 1 liter of milk, okay, 1 liter of kerosene petrol. These are liquids, and the liter or milliliter, all right, these are called the volume of liquid. So by using this device, by using measuring cylinder, we can calculate the volume of liquid. Okay, all right, so this is measuring cylinder, or it could be this one as well. It is also measuring cylinder, this one. Say it. It is a measuring cylinder. It is a big cylinder. These are small cylinders. So you can see the labeling there. Okay. 200 milliliter, 400 milliliter, 600 milliliter, 800 milliliter, 1000 milliliter. 1000 milliliter equals to 1 liter. All right. Okay, 1000 ml equals to 1000 milliliter equals to 1 liter. Did you get the point? 1000 milliliter equals to 1 liter. So this is how we measure the volume of liquid by the help of measuring cylinder. Okay. All right. So students, I think you are clear about that one. Volume of liquid can be calculated. Okay, but we need to take a device that is called measuring cylinder. By the help of measuring cylinder, we can calculate the volume of liquid. And why do we need measuring cylinder? We need measuring cylinder because liquid is a substance which does not have appropriate shape. It has no definite shape, isn't it? When you keep liquid in a glass, then it appears in the shape of glass. When you keep a liquid in a vessel, then it appears in the shape of vessel. That's why liquid is a substance which does not have definite shape, which is why by using measuring cylinder, we can calculate the volume of liquid. And I showed you the picture of measuring cylinder. All right, are you clear? Are you clear? Students, are you clear about that? And if you are clear, then please raise your hand, okay? So that I could understand, so that I could be confirmed that you are clear. Okay, that's great. Very good. Smarika Paudel. Are you clear? If you are clear, then please raise your hand. Are you clear, Smarika Paudel? You
Yes,
can
sir.
speak, your mic is on. Seriously?
Yes, sir.
That is fantastic. All right, now you can switch off your mic. Okay, now, okay, so, and you know one thing is still, let's say you have a small rock, all right? You have a small rock and you found that rock on the way. And do you think that we can calculate the volume of that rock? We can calculate the volume of that rock, okay? Since the rock is an irregular body, still you can calculate the volume of rock by the help of measuring cylinder. Measuring cylinder not only measures the volume of liquid, it also plays significant role to measure the volume of any irregular body, okay? See that. Let me share the screen. All right, students, just a second, okay? Let me share it, right? See that. How do we measure the volume of irregular body? By the help of, how do we measure the volume of irregular body? By the help of measuring cylinder. I'm going to teach you that today, okay? How do we measure the volume? How do we measure the volume of irregular solid? The help of measuring cylinder. How do we measure the volume of irregular solid? What is irregular solid? Irregular solid means without having, you can see definite shape, definite shape, or you can say regular, without having regular shape. That is called irregular body. Okay, so still we can calculate the volume of irregular body. In that case, we'll have to use a device called measuring cylinder. Okay, I showed you the picture of measuring cylinder in our, okay, some moments earlier. Okay, now, so, okay, let me share you a slide, okay, and you'll be clear from that slide. All right. Let me play the slide, okay. All right, see that. So as I told you earlier, how do we calculate the volume of liquid? So you can see, you can read on the slide there. Liquid is a substance which does not have definite shape. As I told you earlier, liquid does not have definite shape. Hence, the volume of liquid is determined, or you can say the volume of liquid can be calculated by measuring cylinder. Okay, as I have already showed you the picture of measuring cylinder, and you know what measuring cylinder is. And the units involved in measurement of liquid, or units involved in the measurement of volume of liquid is milliliter, you can see there, or you can say cc, that is called cubic centimeter, okay, and finally liter, L stands for liter. So these are the units related to volume of liquid. I have already showed you the picture of measuring cylinder. So this is called measuring cylinder. All right. So measuring cylinder is this. So by the help of this device, we can calculate the volume of liquid. Okay. Now you see there. Okay, that pink color. Okay, let's say that pink color is some kind of liquid which has been kept in measuring cylinder. See there. All right. Okay. Now you can check the level of liquid there. What is the level of liquid there? It is 63 ml. Can you see it? So the volume of liquid kept in the measuring cylinder is 63 ml. Did you get the point? So So if you want to measure the volume of liquid, then first you got to see you got to measure, you got to label, you got to measure the height of liquid. So in this case, the height of liquid is 63 ml. Ml stands for milliliter, okay? Which is why the volume of liquid is 63 ml, okay? Now, this is quite important. What is concave meniscus? So let's say basically liquid has two types of meniscus, okay? See there. So if you put water in a vessel, water appears in this shape. You get the point? Water appears in this shape. So see here, the center part is lower. You can see the center part that is depressed. Okay, depressed means it is pushed downward direction. And the edges part, these are the edges. These edges are you can say raised. Okay, the liquid. Listen to me properly, please. The liquid in which the edges, or you can say the sides are raised, and the center one that is depressed. Okay, side one that is raised and the center one that is depressed. Depressed means downward, facing downward direction. Okay, you can say that. So this is called concave meniscus. Usually water is a liquid which shows concave meniscus. Okay, did you get the point? Water is a liquid which shows concave meniscus. See there, what is concave meniscus? You can see the definition there. Some liquids like water, alcohol, milk, kerosene, etc. form a concave surface in the cylinder. It forms a concave surface. All right, I've already showed you the picture in earlier case. This one, see it, see that. Okay, see it. The center one, let's say it is the center one is depressed. हेर त यो तलपट्टि तल फेस गरेको छ, अलिकति तलपट्टि गएको छ त्यो हैन. Center one that is depressed. And this is side one. हेर त साइडमा अलिकति उठेको छ नि, पानी यस्तो हुन्छ के, पानी मात्र होइन, रक्सी, अल्कोहल. Okay, all right. So most of the liquids they appear in concave meniscus. Center one that is depressed and the side one that is raised. This is called concave meniscus. See that. Some liquids like water, alcohol, milk, kerosene, etc. form concave surface in the cylinder. That is, the liquid is depressed at center. Center ma चाहिँ तल जान्छ है, and raised at sides. And side ma चाहिँ माथि उठेको हुन्छ, like this one. At center it is depressed and at side it is raised. Okay, this is called concave meniscus. All right, this is called concave meniscus, and usually water, alcohol, milk, kerosene, etc. form concave meniscus. Okay, this is called concave meniscus. Now let's go to convex meniscus. See here, exactly the opposite of the concave meniscus. Center one raised. Here, center one raised, isn't it? Center one raised and the side one it is depressed. हेर त, बिचको माथि उठेको छ र साइडको चाहिँ यतापट्टि तल बसेको छ. This is called convex meniscus, and convex meniscus is exactly the opposite of concave meniscus. Okay, see that. The liquid like mercury. Mercury is a liquid. Mercury is one kind of liquid element. You might know what the mercury is. Mercury is a liquid element. It's one element which appears in liquid. Okay, without heating, it appears in liquid. So the liquid like mercury is raised at center and depressed at side. Raised at center, depressed at side. This is called convex meniscus. Okay, let me stop sharing. So students, are you clear about concave meniscus and convex meniscus? Students, are you clear about concave and convex meniscus? If you are clear, then please raise your hand. Okay, Deepunj, why your video is off? Rahul, give me, please switch on your mic. Okay, Rahul, tell me, what is concave meniscus?
Concave meniscus is the liquid which is raised at the slides and raised at the center.
Okay. Oh, good. That is the liquid. When you put liquid in a vessel, okay? When you put liquid in a vessel and at side the liquid is raised, isn't it? Liquid is raised at side and at the center that is depressed. Okay, that facing downward. So that kind of liquid is concave meniscus, and usually water, alcohol, milk. Okay, it shows concave meniscus. All right, that's very good. Okay, Avas Powder, please switch on your mic.
Yes, sir.
Okay, Avas, tell me, what is convex meniscus? Convex meniscus.
Liquids like mercury, which are when put in a vessel are raised in the at the center and depressed in the side. In the sides are called the convex meniscus.
Okay, that is wonderful. Great. So let me confirm. Anyone unclear about this one? Please raise your hand. I'm going to repeat, otherwise I shall move forward. Okay. Anyone unclear about this one? Concave meniscus and convex meniscus? Unclear?
Sir, sir, can you repeat about convex?
All right. Now, okay, that's great. Now let me repeat once again. Okay. So if we talk about mercury, let me share the slide. Okay. If we talk about mercury, mercury is one kind of liquid element. All right. See that. If we talk about mercury, when we put mercury in a vessel, just a second, all right, let me fix it. Okay, when we put mercury, let's say it is a vessel, it is a test tube, let's say it is one vessel, and when we put mercury in this vessel, then it appears in this shape. The center one, this is mercury. Okay, the center one, it is raised, and the side one, it is depressed. All right, see the definition there. The liquid like mercury, raised at the center. You can see in the picture there, it is raised. You can see here, raised at the center and depressed at sides. Sideमा हेर त तलपट्टि हेर त के तल साइडमा चाहिँ अलिकति खादिएको छ कि छैन, अलिकति तल गएको छ नि त. Depressed, isn't it? See it, depressed at side and raised at the center. This is called convex meniscus. Okay, it is called convex meniscus. All right.
Sir.
Yes, please.
Sir, your voice
Like,
is
yes,
not
tell me.
coming.
Is it?
Yes, sir.
Okay. Now can you hear me, Alaika? Now can you hear me?
Not clear.
Can you hear me? Okay. Other students, can you hear me clearly? Other students, can you hear me clearly? Then if you can hear me clearly, then please raise your hand. Okay. Okay, Alaika. Yes. Maybe your internet issue. Okay, because all the students are, please hands down. All the students are able to hear me. Since they are raising their hands, that means your internet may be slow. So while the class is going on, please ask your parents, okay, not to use, okay, not to use YouTube or, okay, so that there could be there may be high data traffic, so which is why the voice might not be clear. Anyway, don't worry, I shall share the slide. Okay, at the end of the class, I shall share the slide, and you can learn from the slide as well. All right. Today, let us learn about the. Okay, now let us learn about the. Okay, now let us learn how to calculate the volume of irregular body. Okay, Olaika, please switch off your mic. Olaika, switch off your mic. Good. Now let us learn how to calculate the volume of irregular body. All right. Let's say there is a rock. Okay, and you want to find the volume of that rock. And since the rock which you find on the way, right? Now, can you hear me clearly, students? Can you hear me sound clearly? Okay, good. Abbas, do you hear me? Abbas, do you hear me? Okay, fine. All right, now let's get into the business, okay? Let us learn how to calculate the volume of irregular solid. Let me share a screen. All right, now measurement of volume of irregular solid. Here, okay, the volume of irregular solid can be measured by the help of liquid displacement method. All right, we can calculate the volume of solid by the help of liquid displacement method. The process is called liquid displacement. Okay, in this process we take measuring cylinder. So if we want to measure the volume of liquid, okay, we need to take one measuring cylinder. All right, and we take measuring cylinder, we put some amount of water and note the initial level of water and put in the irregular solid completely dipped in the water, kept in the measuring cylinder, and again note the final level of water and follow the calculation. See in the picture there. Let's say you want to calculate the volume of this stone. Okay, let's say you want to calculate the volume of this stone. It is an irregular stone. All right. And then for this you'll have to take measuring cylinder. This is called measuring cylinder. All right, and put some amount of water in the measuring cylinder. Let's say the initial level of water is 20 ml. You can see here. Okay, V1, that is the initial level of water, initial volume of the water, that is 20 centimeter. And go to the figure number 2. See that. And when you put a stone in that cylinder, in the measuring cylinder, okay, the level of water rises. Okay, the earlier the level of water was 20 milliliter, and when you put the stone, the volume of water that becomes, let's say it is 23 ml. You can see here it is 23 ml. Did you get the point? See that. Initial level of water in the measuring cylinder, that is 20 ml. See here, 20 ml. Before putting stone, before putting the irregular stone in the cylinder, the volume is 20 ml. And after putting stone in the cylinder, measuring cylinder, the volume becomes 23 ml. Okay, when you put stone in the cylinder, its volume rises and that becomes 23 ml. So final level of water in the measuring cylinder, that is 23 ml. Now let us follow the calculation. The volume of stone, okay, the volume of this stone equals to final level of water minus initial level of water. Okay, you should perform this calculation. What is the final level of water? See that the final level of water after putting stone, that is 23 ml, and the initial level of water before putting stone, that is 20 ml. 23 ml minus 20 ml, that is 3 ml. Therefore the volume of stone is 3 ml. Okay, so final level of water after putting stone minus initial level of water, okay, before putting stone. When you decrease this level of water, then you can calculate the volume of stone, okay, or volume of irregular body. So students, are you clear about that one? Okay, I shall share you one slide. I shall show you one video. Okay, I shall give you the link. All right, I shall give you the link on the chat box. Please click that link and watch that video so that you will understand more clearly. Okay, how to calculate the volume of irregular stone.
Now, let us shift our attention from measuring the volume of liquids to measuring the volume of solids. To determine the volume of a regular solid, such as a brick, first measure the dimensions of the object. Then multiply the 3 dimensions and their units. In this example, we measured in centimeters. Therefore, the units for volume are recorded as cubic centimeters. To measure the volume of an irregularly shaped object, such as a rock, measure the volume of the liquid displaced when the object is submerged. To do this, measure the initial volume of water in a graduated cylinder. Submerge the irregular object and measure the final volume of the water. The difference between the initial volume and the final volume is the volume of the object. In this example, the initial volume is 50 milliliters. Dropping the rock in the graduated cylinder causes the water level to rise. The final volume is 81 2/10 milliliters. To find the volume displaced, subtract the initial volume from the final volume. Doing so yields 31 2/10 milliliters. So the volume of the rock is 31 2/10 milliliters. Typically, the reason to measure the volume of an irregular solid is to determine the density of the solid. Density is the mass of a substance per unit of volume. The formula for density is mass divided by volume. You could also find this formula by looking at the formula chart. Using a balance to measure the mass of the rock, we determine that it is 74 88 grams. Since we know that the volume of this rock is 31 2/10 milliliters, and the mass of the rock is 74 88 grams, we can calculate its density. When we divide the mass by the volume, we arrive at 2 4/10 grams per milliliters as the density.
Okay, now listen to me, students. So we'll have to learn only up to how to calculate the volume. Okay, do not worry about density. All right, don't worry about density. We'll have to learn how to calculate the volume of irregular body. So did you get the point? Listen, let me tell you the technique. Okay, first of all, take measuring cylinder. Listen to me, please. Mukta, listen to me. All right. First of all, take measuring cylinder. All right. Let's say it is the measuring cylinder. All right, and it has certain labeling there. 1 ml, 2 ml. It has certain you can labeling the demarcation, calibration, and put some amount of water. Let's say up to 20 ml. Did you get the point? And take one irregular body. Let's say small stone or rock. Put that body in the. So before you put that rock in this vessel, note the initial level of water. Okay, record. Just write on a copy or record the initial level of water and put that stone in that vessel completely. Okay, that stone should be completely deep in the water. And after you put that stone in the water, then the level of water rises. Okay, the level of water increases. And now the volume of stone equals to final level of water minus initial level of water. Okay, final level of water minus initial level of water. So this calculation gives the volume of stone. Let me share the screen once again. See that, please. All right, now see, you can see the calculation there. See here, okay, in this case, right. See there, okay. Now in this case, see here, this device, the vertical one, this device is called measuring cylinder. Let's say, let us put some amount of water in this cylinder. Let's say it is 20 ml. Okay, the initial level of water is 20 ml. You can see there. Initial level of water in the measuring cylinder is 20 ml. That is V1. Measuring initial level, that is noted by V1. That is 20 ml. And let us, this is a irregular rock. Okay, and you want to calculate the volume of this rock. Okay, since it has no proper length, no proper breadth, and it has no proper height, which is why it is very difficult to calculate the volume of this object by using formula L into B into S. It is impossible because it has no proper length. Look at its shape, it is irregular, isn't it? Which is why it is quite difficult, or it is impossible to use formula to calculate the volume of this rock. But by using measuring cylinder, by the help of liquid, we can calculate its volume. So for that we'll have to put that object in the measuring cylinder, all right, which contains certain amount of water. Let's say the initial level of water, that is 20 ml. Okay, that is V1, as I've written there. And after putting the stone, the water level rises, isn't it? And that has become 23 ml. So final level of water in the measuring cylinder, that is 23 ml. Now let us perform some calculation, all right? The volume of stone equals to final level of water, this one, that is V2, minus initial level of water, that is V1, that is 23 ml minus 20 ml, that is 3 ml. Now the volume of the stone is 3 ml or 3 milliliter. You can see the calculation there. V1 20 ml, final volume 23 ml, volume of object, or you can see the irregular stone, equals to 3 milliliter. This is how we calculate the volume of irregular object. Students, are you clear about that one? Diksha, please switch on your mic right now. Diksha Gimire, are you there?
Yes, sir.
Now tell me, how do we calculate the volume of irregular body, like a small piece of rock, small piece of stone, you can say?
First of all, we level the water. First of all, we put the water on the measuring cylinder and we level the
We measure
initial
or
level
we
of
record. Okay, yes, we measure the initial level of water.
Then we put the stone in the measuring cylinder.
All
Then
right.
we note the final level of water.
Very
Then
good.
we do the calculation.
And how do we calculate? What is the formula to calculate the volume of irregular stone or irregular body?
Final level of water minus initial level of water.
All right, very good. Now, why it is impossible to use formula to calculate volume of irregular body? Mukta, please tell me. Mukta, this question goes to Mukta. Why it is not possible to use formula to calculate the volume of irregular stone or irregular body?
It is not possible to measure the volume of irregular body because it do not have defined shape and size.
That's right, it does not have defined shape, because that means it does not have proper length, breadth and height, because it is irregular, twisted one, some part broken, some part unbroken, which is why we cannot use formula. That's why by the help of measuring cylinder, by the process called liquid displacement method, okay, by the process called liquid displacement method, by using measuring cylinder, we can calculate the volume of any irregular body. Okay, not only liquid, we can calculate the volume of irregular stone or any irregular body by the help of measuring cylinder. Okay, and the process is called liquid displacement method by the help of measuring cylinder. And I showed you the picture of measuring cylinder, and I hope you people are clear about that one. Any confusion? Prasumi Khatri, any confusion there?
Yes, sir.
Are you sure?
Yes, sir.
If you are unclear, then talk to me, okay? Otherwise, it will be a problem for you during examination, all right? Okay, good. Now, we are almost end of the today's classroom, so I shall share you the slide. I shall put that slide on the internet, I mean to say on Google Classroom. You will have to learn from the internet, from the Google Classroom as well, and I shall give you some tasks, and I shall examine your work today. Don't worry about that one. And do not, and I would like to tell you one thing, do not miss your homework, okay? You have to submit your assignment before you cross the deadline.